for Fallen Special Operations Forces is here in Tampa at MacDill. The goal of this, the Revision Kinetic Operations Suit.
It's not just the Air Force anymore that is using unmanned aerial vehicles or drones. It is also ground forces at every echelon have different types of drones.
China's military has undergone profound changes in the past decade with upgrades to both equipment and weaponry.
China just equipped its personnel with tech that sounds pulled from a sci-fi movie: powered exosuits, biometric sensors, AI-linked helmets, and even potential genetic enhancements. These aren't rumors. Verified footage and official reports confirm China's military transformation is well underway. In this video, we reveal how China is using machines and biology to digitally enhance humans, turning its ground forces into high-tech, real-time data platforms. Suggesting the suits are part of a larger automated ecosystem shows the BSHV exosuit as more than a prototype. It's a practical field tool already changing the capabilities of individual personnel. As China pushes for more automation and smarter logistics, the powered exosuit stands out as the physical foundation of its enhanced soldier program. The exoskeleton helps humans do the heavy lifting. These sensors track vital signs such as heart rate, hydration, oxygen levels, and stress responses. That data isn't just used to monitor health. It feeds each soldier acts as both a receiver and a sender of information. Their helmets and comm systems can share video feeds, sensor data, and environmental input with remote operators or nearby units. It filters complexity and offers guidance, reducing the time between observation and action. What if the next stage isn't about what a soldier wears, but what did they make of? When combined with the physical power of exosuits, modifications could potentially improve resistance to diseases, or even limited brain-computer interfaces, BCIs, that let soldiers control devices with neural signals. Some reports suggest research is underway into cognitive support drugs that could reduce sleep requirements or sharpen reflexes during extended missions. Speed up muscle recovery. The intent is clear. By combining gene science with wearable tech, it could trigger a race with few ethical guardrails. Nations might feel pressured to develop their bio-upgrade programs. China hopes to build a new kind of human operator, one whose body, mind, and machine work in harmony. Enhanced night vision, or increased tolerance to low-oxygen environments. In high-altitude locations like Tibet, even a small boost in oxygen uptake could radically extend operational stamina. The third pillar of China's enhanced soldier program remains the most elusive and the most controversial. That pillar is biological enhancement, particularly through genetic modification and bio-integrated technologies. The AI-supported soldier becomes a hybrid asset, simultaneously strong, informed, and connected, and the silence surrounding some of its medical trials strongly suggests a long-term ambition in this space. As an intelligent combat cloud, a battlefield network where every element shares what it sees and feels. This setup creates what Chinese white papers describe, and that redefines everything we know about human capability in high-tech conflict environments, directly into central AI systems that help command units assess overall readiness and performance. With Chinese soldiers shown coordinating via tablet interfaces mounted on their chests. These tablets were reportedly linked to AI that can flag anomalies, suggest paths, and even control drones autonomously based on soldier feedback. If a group of personnel starts to show signs of fatigue or oxygen deprivation, while other nations remain cautious about data overload and cybersecurity risks, China is prioritizing rapid implementation. The result is a digitally interlinked force that can adapt instantly to changing circumstances, reroute missions based on live feedback, and respond to threats within seconds rather than minutes. The AI could recommend real-time tactical adjustments or send in support, while drones carry lighter loads and scout terrain. How far have they gone? And what does this mean for the future of global security? Let's break it all down. Terrain maps, target indicators, alerts from command, and the locations of fellow units can all be displayed on the go. Former U.S. DNI John Ratcliffe warned that China was exploring ways to biologically enhance its military personnel, initially dismissed as provocative speculation. More recent reporting from Interesting Engineering and Asia Times has lent weight to those concerns, and remain aware of their full operational environment at all times. In high-altitude exercises conducted in late 2024, these reports point to research partnerships between Chinese military medical academies and national biotech institutes working with gene editing tools like CRISPR. Soldiers can respond faster, maneuver more intelligently, intelligent platform, one constantly guided by artificial intelligence. China's development of powered exoskeletons is no longer a secret or speculative project, it's operational. China is also working to turn each individual on the ground into a connected. Chinese personnel were recorded using powered robotic suits, known as BSHV exoskeletons. China's digital soldier program is tackling that directly by turning every unit into a sensor, processor, and decision-making node. This isn't theoretical. According to footage analyzed by Resonant News, multiple verified drills and open-source reports indicate that Chinese troops are now equipped with AI-connected wearable tech, including augmented reality helmets, HUD visors, and integrated biometric suits. This model is designed to assist hip and leg movement with embedded motors, drastically reducing fatigue and enabling troops to carry heavy supplies like fuel drums and ammunition boxes across rough, mountainous terrain. The BSHV suits feature active power support. These systems have already been deployed during military logistics drills in Tibet. Unlike early passive models tested around 2020, this changes the logistics game entirely. Individual units can move their gear quietly and efficiently. Motors at critical joints provide mechanical lifting force to reduce muscle stress. This data can be used to optimize movement or detect potential injury risks early. The Himalayas present one of the harshest climates for any ground operation, with steep gradients, freezing temperatures, and oxygen-thin air. The fact that these suits are being tested and used in these conditions signals confidence in their ruggedness and real-world reliability. It's part of a broader strategy to digitize soldier performance in real time, allowing the average soldier to carry up to 80 kilograms with greater ease and speed. But in today's battle space, information is power. Rather than needing additional vehicles or pack animals for transport, these suits are also integrated with sensors that monitor gait, posture, and load stress. What makes this application more advanced than earlier versions seen in the West is its use in high-altitude, low-oxygen environments. In drills, soldiers equipped with BSHV exoskeletons were also shown working in tandem with logistics drones. The visual evidence of these drills, confirmed by Global Times and other defense publications. But this mechanical strength is only one piece of a larger transformation. Physical strength may get you through a mountain pass. The system begins with enhanced helmets and smart visors. These tools project real-time data onto the soldier's field of view. That includes wearable EEG sensors to monitor focus, stimulant-based cognitive enhancers. However, the strategic alignment of China's biotech sector with its defense goals. This capability is supported by biometric sensors embedded in uniforms, boots, and even gloves. Perhaps the most game-changing element is the real-time connectivity. This tech was observed in use during 2025's field readiness drills near border training zones. What distinguishes this from similar Western programs is the aggressive pace of integration. This system doesn't replace human decision-making, it enhances it. But what if those enhancements didn't stop at the gear level? While exoskeletons and AI can be tracked through drills and video analysis, in a widely cited 2020 op-ed in the Wall Street Journal, the theoretical applications are staggering. Beyond genetic editing, there is also emerging interest in neurobiological augmentation. Though much of this development remains behind closed doors, there is no direct visual proof that genetically modified soldiers are already in use. The global concern isn't just about the science, it's about the precedent. If genetic enhancement becomes normalized in military contexts, in this ecosystem, the soldier is no longer a product of training alone, they're a product of engineering.